Okay, so for this video, we'll be discussing about control structures in Java. So the objectives at the end of the lesson, the student should be able to, number one, use decision control structures. These are the if, else switch, which allows selection of specific sections of code to be executed. And that is what we're going to do for this video. Then the second two objectives will be for the next video. So this will be divided into two parts. So for the next video, we have the use of repetition control structures, the while, the do while, and the for loops. So which allow executing specific sections of code a number of times. And then use branching statements, the break, continue, and return, which allows redirection of program flow. Control structures. Control structures allows us to change the ordering of how the statements in our programs are executed. So instead of executing the code in sequence, then the control structures will change the ordering of how the statements in our program are executed. So there are two types of control structures. These are the decision control structures, which allows us to select specific sections of code to be executed. And then we have the repetition control structures, which allows us to execute specific sections of the code a number of times. And this will be explained further on the next slides. So the decision control structure. Decision control structure, the Java statements that allows us to select and execute specific blocks of code while skipping other sections. So we have three types here. We have the if statement, and we have the if-else statement, and the if-else-if statement. So the if statement. The if statement specifies that a statement or block of code will be executed if and only if a certain Boolean statement is true. So the if statement has the form if, and then we have here enclosed in parentheses the Boolean expression. Then we have here the statement. So that is if we have only a single statement. But if we have a block of statement, then we have to use the open and close curly braces. So if the Boolean expression, so if this is true, it will execute statement 1, statement 2, and maybe more statements. So where the Boolean expression is either a Boolean expression or a Boolean variable. So as long as its value can be true or false. And what are Boolean expression? This is where we use the comparison operators like lesser than, or relational operators like lesser than, greater than, and also sometimes the Boolean operators. So the if statement, if it is in the flowchart form, will be something like this. You have the Boolean expression here. So if the Boolean expression is true, then the control passes through this flow. It will execute the statement and then it goes out. So if, for example, the Boolean expression is false, then it will just, the control will pass this flow and then that's it. It will not execute the statement if it is false. So it will only execute this if the Boolean expression is true. So we have here an example. Integer grade is equal to 68. If grade is greater than 60, then system that out that print line congratulations. So let's try that. So will this print congratulations? Yes, because 68 is greater than 60. So let's try that. So I'll be copying this. Wait, Control C, and then let's place it in my online Java compiler. Okay, so that's our code. So I just copied the code from the slide, and then once I run the program, it displays congratulations. Why? Because 68, the grade is 68, is greater than 60, so it will do this one. So what if, let's say the value is lesser than 60, let's say 55. So what will happen? If you run the program, you notice nothing is displayed. What if it is 60? So is 60 greater than 60? Of course, it is not greater than 60. So it will not also display congratulations. So if the grade is now greater than 60, let's say 61 and above, then that's the time it will print congratulations. Okay, so that's the use of the if statement. So let me delete this one first. And then let's proceed. Example number 2. Grade is equal to 68. Then if grade is greater than 60, then we have a block here. So there are two statements inside. We print congratulations, and then on the next line it prints you passed. So let's try that. So bottom line here is we use the open and close curly braces if we want to execute a block of statements. Oh, wait. So I'll copy, then I'll paste, beautify to make my code better. So that's it. If I run the program, so it will print congratulations and then you passed. If I change my grade to, let's say, 55, if I run the program, it doesn't print anything. Okay, so let's go back to our slide. Coding guidelines. The Boolean expression, or it's a part of statement, should evaluate to a Boolean value. That means it can be true or a false value. That means that the execution of the condition should either result to a value of true or false. Then indent the statements inside the if block. So if you have a block, then you indent. That will make the code readable. Okay, so these are the guidelines. Then next we have the if-else statement. If-else statement used when we want to execute a certain statement if a condition is true, and a different statement if the condition is false. So in the first example, we only execute a particular statement if the condition is true, but we don't execute anything if it is false. But for the if-else statement, then we'll be executing a statement if it is true, and another statement or a different statement if the condition is false. So this is now the form or the syntax of the if-else statement. If Boolean expression, so that's a Boolean expression that can be true or false, then we have the open curly braces, so this is our block. Then we have here the statements that will be executed if the Boolean expression is true. Else, then we have here the statements that will be executed if the Boolean expression is false. So in the flowchart, it is something like this. So we have here the condition, the Boolean expression. If this is true, then it will execute this block of statements, or statement or block of statements. If it is false, it will execute a different block of statement or statements. Then it exits the block. So that's a flowchart. So for example here, if the grade is equal to 68, if grade is greater than 60, system.out the print line congratulations. Else system.out the print line sorry you failed. So this time we have two options here. If it is greater than 60, if it is true, it will print this one. If this is false, it will print sorry you failed. So let's try this in our online compiler. Okay, so I hope you can see our code here. So here, integer grade equals 68. So grade is 68. Is it greater than 60? Yes. So we're expecting that it will print congratulations. So let's try to run the program. So there, it printed congratulations. What if I change my value, let's say to 55, and run the program? It says here, sorry you failed. So it will only execute this if this Boolean expression is false, and it will only execute this if this Boolean expression here is true. So we have here a second example, this time around using a block of statements. So almost similar, greater than 60, we print congratulations, you passed. If not, we print sorry, you failed. So let's try to execute this program or to run the program. Oh wait. So that's our code. I copied and pasted, and then let's try to beautify. So initially our grade is equal to 68, so we're expecting this to be true. So it will print supposed to be congratulations and you passed. It will not print sorry you failed. So we have congratulations, you passed. So what if I change my grade to 55 again? So if I run the program, then it will do the statements in our else block, which is actually sorry you failed, because this one now is false. Okay, so let's continue. Coding guidelines. To avoid confusion, always place a statement or statements of an if or if-else block inside brackets. In fact, even if, let's say you have a single statement, just place it inside the brackets. You can have nested if-else block. This means that you can have other if-else blocks inside another if-else block. For example, we have here our if-else block, and then inside the if-else block, we have another if block or if-else block. Okay, so that's possible. We can have nested if-else blocks. So next we have the if-else else if statement. So the statement in the else clause of an if-else block can be another if-else structure. So this cascading structure allows us to make more complex selections. The statement has the form if Boolean expression. So if this is true, we have the statement that will be executed. Then we have else if, another Boolean expression. If this is true, another statement. So we can have another else if, else if, else if, and then maybe on the last we have else, and then the statement that will be executed if none of this expression is evaluated as true. So for a flowchart, it will be something like this. If the Boolean expression is true, execute the statement, then it goes out. If not, then we have another condition. So if this is true, execute this statement, goes out of the block. If not, then we have the else statement 3, then it goes out of the block. So that's if, else, if. So as an example here, integer grade equals 68. So if grade is greater than 90, then this will be printed. Very good. If not, if grade is greater than 60, so that means greater than 60 but lesser or equal to 90, because it will only go to this place if the grade is not greater than 90. That means it is lesser or equal to 90. So it will be printing very good. And if the grade is 60 and below, then it will print sorry you failed. So we have here 3 options. So let's try this in our code. Wait. Okay. So I'll be pasting that here. And beautify. So I have here my code. Oh, I think I wasn't able to erase the previous one. I'll delete. Okay, so that's our code. So grade now is 68. So what do we expect? It is false here, true here. So we're expecting a very good output. So we have here very good. Because it is false here, the 68 is not greater than 90, and 68 is greater than 60, so it will print very good. What if we have 55? So 55 is not greater than 90, 55 is not greater than 60, so it will print sorry you failed. So there, sorry you failed. What if we have a grade of 91? So 91 is greater than 90. So we're expecting that the output will be very good. Oh, why is it the same? Very good. Let's change this one to excellent. Okay. So we run the program. Displays excellent. So initially this is 68. 68 should be very good. Okay, so that is our program. Sorry for the code. I think there's something wrong with this code. Common errors. The condition inside the if statement does not evaluate the Boolean value. For example, integer number equals 0 if number. So number is not true or false. So that means this is wrong. So the variable number does not hold a Boolean value. So another common error is writing else if with no space instead of else space if. And also, instead of using double equal for equality comparison, we use single equal. For example, integer number equals 0 if number equals 0, that's wrong. It should be number, then we have double equal, and then 0. So that's the correct format. So an example program again. So let's copy this. Let's copy the code. To remove the lines. So I have to remove the line number 8. So that's our code. We have here 92, a grade of 92. Is it greater than 90? Yes, so we are expecting it to be excellent. So that's the output. So what if our grade, so something that's lesser than 90 but greater than 80. Let's say, for example, we have 85. So, we have 85, a grade of 85. So if 85, that should be false here, but true in this condition. So 85 is lesser than 90 and at the same time greater than 80. So it should be printing good job. So we have good job. So what if lesser than 80 but greater than or equal to 60? So let's say, for example, we have here 75. So we run the program. It will display study harder because 75 is not higher than or equal to 90. It is lesser than 90, but it is not greater than 80. So it is false here. Here, it is lesser than 80, yes. And is it greater than 60? Yes. So it is true in this expression. So therefore, it will print study harder. So that's our example program. Then next, we have the switch statement, which is actually similar to the if statement. This allows branching on multiple outcomes. The switch statement has the form switch and then the switch expression, case and then the case selector 1 colon. So please take note of the syntax. The statement, and then we should have here a break. Because if we don't have here a break, it will continue executing the statements, the rest of the switch block or the switch statement. Okay. So we have to place here a break, case selector 2, statement, break. Default, so this is as if our else block, statement 1, statement 2, and then that's it. So where the switch expression is an integer or character expression. And the case selector, and so on are unique integer or character constants. So we actually compare the integer expression with the case selectors. So when a switch is encountered, the Java first evaluates the switch expression and jumps to the case whose selector matches the value of the expression. The program executes the statements in order from that point on until a break statement is encountered, skipping then to the first statement after the end of the switch structure. So if none of the cases are satisfied, the default block is executed. Take note, however, that the default part is optional. Note, unlike with the if statement, the multiple statements are executed in the switch statement without needing the curly braces. When a case in a block statement has been matched, all the statements associated with the case are executed. Not only that, the statements associated with the succeeding cases are also executed. To prevent the program from executing statements in the subsequent cases, then we use the break statement. So take note of that. So again, the statements associated with the succeeding cases are also executed. But if we don't want to do that, then you have to insert a break statement. So the flowchart is something like this. We have the case selector. If it is true, execute the block statement, break, and then it goes out of the block. If not true, then the next selector. If true, execute, go out. Then if not, the third selector, etc. Then if none of the selectors there's no match among the selectors, then the default block statement is executed. So for example, we have here integer grade equals 92. So switch grade, case 100, case 90, case 80, and then we have here. So let's try this. Let's remove our line numbers. Oops. And beautify. I want to place these statements below. Let me arrange my so that's how it does it. Okay, so I'll just have it this way. Okay, so our grade is 92, switch grade. So we compare grade with these selectors here. So if you run the program, sorry, you failed. Why? Because we don't have a 92 here. So I'll just have this as 90 because these are just exact matches. So 90, we have good job. So if this one is 80, then we have study harder. If it is a grade 70, then sorry, you failed. So coding guidelines. Deciding whether to use an if statement or a switch statement is a judgment call. So it's your call. You can decide which to use based on readability and other factors. An if statement can be used to make decisions based on ranges of values or conditions, whereas a switch statement can make decisions based only on a single integer or character value. Also, the value provided to each case statement must be unique. Okay, so that ends my video about decision controls. So on the next part of this video will be about repetition controls. So thank you very much for viewing this video.